Welcome students. In lecture number 1 about curve tracing, we learn 5 rules to trace a Cartesian curves. So now in lecture number 2, we will implement those 5 rules to trace a Cartesian curve. So let's begin with lecture number 2. So let's start with first equation, that is y square into in bracket x minus a equal to a square into in bracket 2a minus x. As you can see, this equation is in terms of x and y. That means this equation is in Cartesian format. So we want to trace that equation on x or y plane. So in lecture 1 we have understood that how the 5 rules are applicable and how to find out whether any curve follows these 5 rules or not. So one by one we have to apply previous 5 rules here, and according to that we have to trace our curve on this x or y plane. So let's start with first rule, that is symmetry. So you can easily check the y power is 2, which is e1, then your curve is symmetric about x-axis. But x power is 1, which is not e1, then curve is not symmetric about y-axis. Similarly, if we replace x with minus x and y with minus y, then the equation will totally change. Hence, it is not symmetric about opposite quadrant also. Next, if we interchange x and y, then also equation will change, then it is not symmetric about y is equal to x line. So one by one we have to check all the 6 type of symmetry here, and we have to find out which this curve is follows which type of symmetry. So here only we are getting one type of symmetry, that is x-axis symmetry, because y powers are even. Okay, so how we can draw whether your curve is symmetric about symmetric about x-axis or not on x or y plane. So we will use the shade area. Here it shows that you have to draw your curve only above to x-axis, and because of this x-axis symmetry we will trace directly below to x-axis. Okay, now come to the second rule, that is whether your curve is passing through origin or not. So here this curve will not pass through origin. Why? Because if you put x equal to 0 and y equal to 0, then the left hand side is total 0. But the right hand side is 2a cube, which is not equal to 0, means your curve equation is not satisfied by 0, 0. Hence, your curve is not passing through origin. So we will not put origin in your x or y plane. Now the third is intersection with coordinate axis. So first we need to find out the intersection with x-axis. So what is the equation of x-axis? That is y equal to 0. So we will put y equal to 0 in the given equation. Okay, so if we put y equal to 0, so because of this y, your term is 0. Okay, so left hand side is total 0 because y is 0. But here with this we are getting a square into 2a minus x is equal to 0. If we solve it, so we will get x is equal to 2a. So we are getting, if we put y is equal to 0, then we will get x equal to 0. So what point we are getting? That is 2a comma 0. Okay, so we will just put 2a comma 0 point on the x-axis. Okay, now we will get this point on the x-axis. So I already told you, whenever we have any point, we need to find out tangent at that point. Without tangent, we are not able to draw our curve. Okay, so to find out tangent, what we have to do? We have to differentiate this whole equation with respect to x. Okay, so what you have to do? You have to find out y square, and all x terms you can take on right hand side and then differentiate. Then y square differentiation will be 2y dy by dx. Okay, now just find out dy by dx and put the value of x as 2a and y as 0. Okay, so if you will do this, then you will get that dy by dx at 2a 0 point is infinity. Okay, so here you will get dy by dx is equal to infinity at this point. Okay, and if it is infinity, so I already explained in lecture number 1 that if dy by dx, that is slope of the tangent, is infinity, then the tangent is parallel to the y-axis. Okay, so at 2a 0 point here we will show our tangent as 2a. At 28.0, the tangent is parallel to y-axis. This green line denotes the tangent at 2a 0 point. Okay, now come to the rule 4. Rule 4 is about asymptotes. Okay, rule 4 is about asymptote. We have to discuss here two types of asymptote: parallel to x-axis as well as parallel to y-axis. Okay, so parallel to x-axis, what we have to find out? The highest degree of x. So here again in this equation, the highest degree of x is 1. Okay, left hand side, that coefficient of x is y square, and right hand side coefficient of x is minus a square. If we take both term on the left hand side, altogether the x coefficient is y square plus a square. Okay, so we have to put this as 0, so we will get y is equal to plus minus ai. Okay, that means we are getting imaginary asymptotes, so we have to neglect it. So here we are getting two parallel to x asymptotes, but both are imaginary, so we will not take it, or we will neglect it. Okay, now so on a similar way we have to find out parallel to the y-axis asymptote. So what is the highest degree of y in this equation? So y degree is 2 and its coefficient is x minus a. So we have to put x minus a is equal to 0. So we will get the asymptote as x is equal to a. Okay, so now we have to draw this x is equal to a asymptote on xy plane. Okay, so this red line denotes x is equal to a line, which denotes the asymptote. Okay, so I think it is clear to you how to find out asymptote, and if you will get any asymptote, you have to draw that asymptote line on the xy plane. Okay, now the last rule, that is region of absence. So for region of absence, you have to solve your equation is either for x square or for y square. Here we are having x power is 1, so obviously this equation is not solvable for x. So we will solve it for y square, or we will rewrite our equation as y square is equal to 2a minus x upon x minus a. Okay, so here the x-axis is varies from minus infinity to infinity, so we have to break it. How we can break it? So we have to put denominator and numerator equal to 0. So if we put numerator 2a minus x is equal to 0, so first value we are getting x is equal to 2a. Now if we put denominator is as x is equal to a, we will get if we put denominator as a 0, so we will get x is equal to a. So we are getting two values of x, that is a and 2a. So here we will get 4 points on the x-axis. First is this minus infinity, second is a, okay, now third is 2a, and last one is infinity, okay, which is denoted from yellow mark on the x-axis. So in all we are getting three parts. One is minus infinity to a, second part is a to 2a, and the last part is 2a to infinity. Okay, so now we will write down it mathematically, and we will check whether y square is negative or positive. Okay, so the first part is x is greater than minus infinity but less than a. Okay, if x is less than a, then obviously 2a minus x is your positive value. But if x is less than a, then x minus a is your negative value. So y square positive upon negative, which is negative, so curve does not exist. Okay, now the second part is if x lies between a to 2a, means x is greater than a but less than 2a. If x is greater than a, then obviously denominator, that is x minus a, is positive. But if x is less than 2a, then also numerator is also positive, because 2a minus x is positive. That means your y square is altogether positive. That means your curve exists. Okay. Now the last, if x is greater than 2a. If x is greater than 2a, then numerator, that is 2a minus x, is your negative value, while denominator, that is x minus 2a, is positive value. So altogether y square will be negative, hence curve does not exist in this region. So here now we will use the shaded part in your XOY plane where the curve does not exist. So from minus infinity to a and from 2a to infinity, curve does not exist. So only we are getting one strip, that is x is equal to a red line to x is equal to a green line where the curve exists. So only here we will draw our curve. Okay. So remember that point at tangent, your curve will pass through that point and touch your tangent line, and at asymptote your curve will be parallel at the end of the asymptote. So we have to just draw our curve at the point where it is passes, and while that passing through that point, your curve should touch the tangent, and on second point we have to draw the curve at asymptote. So how we can draw that curve at asymptote? So we have to, at last, our curve branch should be parallel to the asymptote line. Okay. So like this. So here this branch near to red line is parallel to the asymptote, that is red line, and here at 2a point your curve touches the green line. Okay. So that two part you have to draw. Now you have to smoothly join these two parts. Okay. So this is our curve above to x-axis. Now because curve is symmetric about the x-axis, so same graph we will draw below to x-axis, like that. So it is your curve tracing for the given equation. I hope it is clear to you. So let's start with new curve, that is y square is equal to x minus 1 into x minus 2 into x minus 3. So again it is Cartesian curve, so we will draw this curve on XOY plane. Okay, so let's start with first rule, that is symmetry. So here y power is e1, then the curve is symmetric about x-axis. Okay, but the x powers are not even, so curve is not symmetric about y-axis. Even if we interchange x and y sign, then the curve will change. So the curve is not symmetric about opposite quadrant. And also if we interchange x and y, then also curve equation will change. So curve is not symmetric about y is equal to x line. So only one symmetry we will get here for this curve, that is about x-axis. Okay, so we will draw the shaded part below the x-axis, so it will be easy to identify that the curve is symmetric about x-axis. Okay, now come to the second rule, that is origin. So we have to check here whether curve is passing through origin or not. So we have to put here x equal to 0 and y equal to 0. So if we put y equal to 0, then the left hand side is 0. But if we put x equal to 0, then the right hand side is minus 1 into minus 2 into minus 3. Altogether it is minus 6. So if we put x and y both as 0, so we will get 0 is equal to minus 6, which is not possible. Hence the curve equation is not satisfied by the origin point, that is 0, 0. So curve will not pass through the origin. Okay. So now third point, that is intersection with coordinate axis. So we will find out the intersection with x-axis. X-axis equation is y equal to 0. So we will put y equal to 0 in this equation. So if we put y equal to 0 in this equation here, so we will get x is equal to 1, x is equal to 2 and x is equal to 3. So if we put y equal to 0, so we will get three values of x, that is x equal to 1, x is equal to 2 and x is equal to 3. Okay, so we will get 3 points which intersect on the x-axis are 1, 0, 2, 0 and 3, 0. Okay, so we will draw these 3 points on the x-axis, that is first point, that second point, third point. So it is 1 0, 2 0 and 3 0. I already told you, whenever we will get any point, we need to find out tangent at that point. Okay, so what we will do, we will differentiate this equation with respect to x. So we will get 2y dy by dx is equal to some function of x. Okay, so y will goes in the denominator. So every time if we put any point 1 0, 2 0, 3 0, that means y is 0. So we will get dy by dx is equal to infinity. So we are getting dy by dx is equal to infinity for all these 3 points, that is 1 0, 2 0 and 3 0. That means your tangent will be parallel to the y-axis and passing through these 3 points. So now the first tangent at 1 0 will be parallel to the y-axis. Same for 2 0 and 3 0 point. So here green lines, 3 green lines are denoted the tangents at 1 0, 2 0 and 3 0 point. Okay, so that is rule 3, intersection with the coordinate axis. But now here intersection with the x-axis, if we have to find out, we already find intersection with the x-axis. But now if we have to find out intersection with the y-axis, so y-axis equation is x equal to 0. So if we put in this equation x equal to 0, so we will get y square is equal to minus 1 into minus 2 into minus 3. That means y square is minus 6. That means y will be imaginary. That means there is no intersection on the y-axis. I hope it is clear to you. Okay. Now come to the fourth point, that is asymptotes. Okay. So asymptote, we have to find out the highest power of x and highest power of y. So if we have to find out asymptotes which are parallel to x-axis, so we have to find out the highest power of x. If we open these brackets and multiply it, so we can see that the x highest power is 3 and x cube coefficient is 1, which can't be 0. That means there is no parallel asymptote to the x-axis. Similarly, the highest power of y is 2 and here also coefficient of y square is 1. That means 1 can't be 0. So there is no asymptote parallel to the y-axis also. So in all, there is no asymptote. Okay. So now come to the directly fourth point. So fourth point is now region of absence. So this equation is already solved for y square. So we will take it like this only, that is y square is equal to x minus 1 into x minus 2 into x minus 3. So now this x-axis, total x-axis is now divided into 4 points, 5 points, that is infinity, then x-axis 1, then 2, 3 and plus infinity. So total it will divide into 4 point parts, that is minus infinity to 1, then 1 to 2, then 2 to 3 and 3 to infinity. Okay, so now we will check one by one on each part whether your curve is exist or not. So I'll just recall here, when your y square will be negative, then curve does not exist. If your y square will be positive, then curve will exist in that particular region. Okay. So now the first is minus infinity to 1. That means x is less than 1. Okay. So if we put here x is less than 1, then x minus 1 will be negative. X minus 2 will be negative. X minus 3 is also negative. So negative, negative, negative will be negative. So y square will be negative. That means curve does not exist. Okay. So we will draw this part here. So with the shaded part, that shaded part will denote that curve will not lie in that particular region. So that part where the curve does not exist. Okay. Now take the second part, that is 1 to 2. Means x is greater than 1 but less than 2. So if x is greater than 1, then x minus 1 will be positive, but less than 2, then x minus 2 is negative, and x minus 3 is also negative. So it is positive, negative, negative. That means altogether y square is positive. Y square is positive, that means curve will exist. So we will not fill it with the shaded part. Okay. Now the third part is 2 to 3. So 2 to 3 means x is greater than 2 but lesser than 3. Okay. So if x is greater than 2, then x minus 1 is positive. X minus 2 is also positive, but x minus 3 is negative. So positive, positive, negative. Altogether y square will be negative. That means curve does not exist. So again we will fill that 2 to 3 part with the dash part, shaded part. Okay. Now we have to check last part, that is 3 to infinity. So if x is greater than 3, then x minus 1 is positive, x minus 2 positive, and x minus 3 is also positive. So y square will be altogether positive. That means curve exists. So we will not fill it with the shaded part. Okay. So that's all. We have discussed all the 5 rules. Now we have to here draw. Okay. So here we will draw a curve firstly in between 1 to 2 part. So by this you can easily see that at 1 2 green line is your tangent, and 2 0 also green line is tangent. So curve will pass through this tangent by touching it. Okay. So how it will be? So see here, it will touch like this. Okay. Now again your curve is exist in the last part, that is 3 to infinity, and at 30 point your curve tangent is that green line. So again your curve will touch at 30, that green line, then curve will be like this. Okay. So now we have to just smoothly join all the lines. So here you will get this type of curve. And you know curve is symmetric about the x-axis. So same image we will draw below to the x-axis. So this one and this one. So that is our curve for y square is equal to x minus 1, x minus 2 into x minus 3. Okay. So I hope it is clear to you. Okay. So let's start with the third example. So now next example is y square into x square minus 1 is equal to x. So again we will draw this curve on x or y plane. So we will go rule by rule to check which properties are satisfied by this curve, and according to that we will draw our curve. So the first rule is about symmetry. So here you can see easily that y power is 2, which is even. So the curve is symmetric about x-axis, and no other symmetry rule is satisfied by this curve. Okay. So only the curve is symmetric about x-axis. So we will draw a dashes shaded area below to the x-axis, so that you can remember that curve is symmetric about x-axis. Okay. So now come to the rule 2. Rule 2, whether our curve is passing through origin or not. So for to check this, we have to put x equal to 0 and y equal to 0. If we put x equal to 0 and y equal to 0, then curve equation is satisfied. Hence the curve is passing through origin. So we got origin as a point on the curve. Now we have to find out tangent at this origin point. So for that we have to rewrite our equation by separating the degrees term. So if we open the bracket and we will rewrite our equation. So the equation is x square y square. X square y square, that means it is of 4-degree term, minus y square, that is of 2-degree term, and minus x, that is of 1-degree term. So this is our equation by separating the degrees term. Okay. Now here for tangent at origin we have to put the lowest degree term is equal to 0. So we have to put minus x is equal to 0. If we solve it, then we will get x equal to 0. So x equal to 0, that is y-axis is our tangent at origin. So we will draw the tangent point and tangent at origin on x or y plane. So see 0 0 by this yellow mark shows that 0 0 is lies on the curve, And now y-axis turn into green because we took green color for tangents here. So here y-axis is your tangent now. Okay, now come to the third rule, that is intersection with coordinate axis, that is x-axis or y-axis. So we can see there is no intersection with x-axis or y-axis other than this 0, 0 point, because if we have to find out intersection with x-axis, we have to put y equal to 0. So if we put y equal to 0, we will get x equal to 0 only. That means the point is only 0, 0. Similarly, if we have to find out intersection with y-axis, so we have to put x equal to 0. So by putting x equal to 0, we will get y equal to 0. Means we will get only 0, 0 is the one point which is intersection with both the axes, that is x and y. And we already discussed this point in the rule number 2, so no need to discuss it again here. Now come to the rule 4, that is asymptotes. So we have to find out here both type of asymptotes, that is asymptote parallel to x-axis and asymptote parallel to the y-axis. So to find out asymptotes parallel to the x-axis, we have to find out the highest degree of x. So in the equation, the highest degree of x is 2 and its coefficient is y square. So we have to put y square equal to 0. So we will get y is equal to 0 and y equal to 0. That means x-axis, right? So now, but we are getting here x-axis as an asymptote 2 times. Got it? So whenever you will get y square, y cube is equal to 0 and you have to put it as 0. So don't write down directly y equal to 0. You have to put that number of times, right? Like here y square is 0, so we have to put it as y equal to 0 and y equal to 0. It will give you the clear picture that how many times that is your asymptote for the curve. Okay, so now here y equal to 0, y equal to 0 are asymptote for the curves. Okay, now find out asymptote parallel to the y-axis. So we have to find out the highest degree of y. So in the again curve equation, the highest degree of y is 2 and its coefficient is x square minus 1. So we have to put here x square minus 1 equal to 0. By this we will get either x is equal to plus 1 or minus 1. Now we will draw all these three asymptotes on our xy plane. So the first one is y equal to 0, that is x-axis. So now x-axis converts into red color I took for asymptote. Okay. Now next one is x is equal to minus 1 and third is x is equal to 1. Okay. So how it is different from the previous example, because here we are getting y equal to 0 asymptote 2 times. So what does it mean? That y equal to 0, if your asymptote 2 times, then curve is parallel from the above two x-axis also and from the lower two x-axis also. From both sides your curve will be parallel. Okay, while x is equal to minus 1 is the asymptote only one time, then either curve will be parallel to the right hand side or from the left hand side. It is dependent on where the curve exists, but it will not pass from the both side because your asymptote is only one time. You are getting that as only one time. Okay, so I hope it is clear. So let's go for next rule, that is region of absence. So you can easily see that your equation is solvable for y square. So you can rewrite your equation as y square is equal to x upon x square minus 1. Okay, so to find out or to break x-axis, that is minus infinity to plus infinity, into parts, we have to put the numerator of this equation is equal to 0 and denominator also as 0. So we will get 3 points, that is x equal to 0, x is equal to minus 1, x is equal to plus 1. So now the whole x-axis minus infinity to plus infinity is divided into 4 parts. First part minus infinity to minus 1, second part is minus 1 to 0, and third part 0 to 1, and last part is 1 to infinity. Okay, so by the previous methods we will check whether y square is negative or positive. So by the same method, what we are getting, if x is lies between minus infinity to minus 1, that means what, x is negative but strictly less than minus 1. X is strictly less than minus 1 means x numerically greater than 1. Okay, so just keep this in mind and just identify whether y square is positive or negative. So here x is negative, that means numerator is negative, and x is numerically greater than 1, that means your x square minus 1 is positive. So y square is altogether negative, so curve does not exist. Next part is minus 1 to 0. So here the curve is y square value is positive, so curve exists. On the same way we will find out 0 to 1. Again y square is negative, so curve does not exist. And in the last part y square is positive, then the curve is exists. Okay. So now we will take the dashes area which will show your curve does not exist in that particular region. So first one, it is 0 to 1. So 0 to 1 now dashes area, that means curve does not exist in that region. And minus infinity to minus 1 also curve does not exist. Okay. So now we have to draw our curve only in two areas, that is x is equal to minus 1 to x is equal to 0 line, and the last is x is equal to 1 to infinity region, right? So how we will denote, draw? So first we will draw our curve at the tangent. So x equal to 0 is your tangent and x is equal to minus 1 is your asymptote. So x is equal to 0 pe your curve will touch green line, and at x is equal to minus 1 your curve will be parallel to the asymptote. So it is like this. Okay. Now we will draw our curve from 1 to infinity. So from 1 to infinity your curve is this x is equal to 1, red line is asymptote, that means your curve is parallel to this x is equal to 1 line, and this x-axis is also your tangent asymptote, sorry, x-axis is also your asymptote, then it is parallel to that x-axis also. So it is like this. Okay. Now we have smoothly joined all the things, so we will get this type of curve. Okay, and the first point is symmetric. It is symmetric about x-axis, so we will draw the same curve below to x-axis also. So it is like this and it is like this. So this is our curve. Okay, it will shows like this. Thank you. So now next example, y square into 4 plus x square is equal to 4x square. So we will draw this curve on xy plane. So let's start with first rule, that is about symmetry. So in this equation you can easily see that your equation is symmetric about both the axes, as x and y both are having even powers. So here this curve is symmetric about both the axes. So we will take the shaded area to denote the symmetry. So we will put the shaded area below to x-axis because curve is symmetric about x-axis, and left to y-axis because the curve is symmetric about y-axis also. Okay. So now come to the rule 2, whether your equation is passing through origin or not. To check this, we will put x equal to 0 and y equal to 0 in the equation. So equation is satisfying by 0, 0. That means your curve is passing through origin. So if curve is passing through origin, so we will find out the tangent at origin. So to find out tangent at origin, we have to rewrite our equation by separating the degrees term. So we will rewrite our equation as x square y square plus 4y square minus 4x square equal to 0, right? So here you can find out that x square y square is 4-degree term, 4y square is 2-degree term, and minus 4x square is also 2-degree term. So here we are getting lowest degree term is a 2-degree term, which is a group of two terms, 4y square minus 4x square. So we will put all together 4y square minus 4x square equal to 0. So with this we will get y is equal to plus minus x. That means we are getting two real but distinct tangent at origin. That means your point should be of type of node. Okay, so what does it mean, node point? That your branches of the curve will be widely open at the node point. So we will draw that origin and tangent at origin on the xy plane. So this is the point 0 0. At this point y equal to x and y is equal to minus x, both are tangents. Okay, now come to the third rule, that is intersection with coordinates axis. So there is no intersection with coordinates axis, because if we put x equal to 0, then we will get y equal to 0, and if we put y equal to 0, then we will get x equal to 0. That means 0 0 is the only point which is intersection with the coordinate axis x and y, and we have already discussed this point in the rule number 2, so there is no need to discuss it again here. Okay, now come to the rule 4, that is asymptotes. So we have to find out two types of asymptote. One is parallel to x-axis and next is parallel to y-axis. So for the first type of asymptote, parallel to x-axis, we have to identify the highest degree of axis. So here highest degree of x is x square. So x square is in the left hand side and its coefficient is y square, and on the right hand side its coefficient is 4. So if we combine the coefficient of x square, then it will be altogether y square minus 4, and we have to put it as 0. So we will get y is equal to plus 2 and minus 2. So here we are getting two asymptotes, that is y is equal to 2 and y is equal to minus 2. Let's draw these two asymptotes on the xy plane. So that is y equal to 2 with red lines, and that is y equal to minus 2. Okay, now just find out asymptote parallel to the y-axis. So what is the highest degree of y? That is again 2, that is y square, and its coefficient is 4 plus x square. So we will put 4 plus x square equal to 0. That means we will get x is equal to plus minus 2i. That means imaginary asymptote. So we will not take these imaginary asymptotes. We have to take only real asymptote. So we will write down hence no asymptote parallel to the y-axis. Okay. So that is rule number 4 about asymptotes. Now come to the last, that is region of absence. Okay, now for this particular equation, you can find out this equation is also solvable for x square and for y square too. Okay, so we will solve our equation first for y square. So we will get y square is equal to 4 x square upon 4 plus x square. If you put denominator and numerator equal to 0, so you will get only real value of x as 0. So minus infinity to infinity will divide into two parts, that is minus infinity to 0 and 0 to infinity. Now you can easily check for both, you will get y square as positive, because x square whenever appears, it is appears as a x square. So x square is always positive, hence y square is always positive. Okay, that means curve exists for all values of x, minus infinity to plus infinity. Okay, now we can rewrite our equation by solving this equation for x square. So you will get x square is equal to 4y square upon y square minus 4. If you put denominator and numerator of this equation of right hand side is equal to 0, then we will get y equal to 0, y equal to 2 and y equal to minus 2. So now minus infinity to plus infinity, y axis is divided into four parts, that is minus infinity to minus 2, minus 2 to 0, 0 to 2 and 2 to infinity. Okay, so I will not elaborate again here. You will just put these values on in the equation and check whether x square is positive or negative. So in the first part x square is negative, second part x square is positive, third part positive, fourth part negative, right? So curve exists only from minus 2 to plus 2. So if we draw the dashed line, so here the curve does not exist above to y equal to 2 and below to y equal to minus 2. Okay, so this all rules we have just put on the XOY plane. Now we have to draw. So we start drawing our curve at or tangent and at asymptote. So at 0 0 y equal to x and y is equal to minus x, we are having tangent. So curve will be like this here, and x is equal y equal to 2 is your asymptote. So curve will be parallel to the red line and touch to the green line. Now you have to smoothly join this. So this is the curve in the first quadrant, because now curve is symmetric about x-axis. So curve will be exactly same as this below to x-axis. Now the curve is symmetric about y-axis also. So curve will be like this in the left hand side of the y-axis. So this is your curve look like. Okay. So now let's go for the next example. So next example is y square into 2a minus x is equal to x cube. Okay. So again we will take XOY plane first. So here it is your XOY plane. Now we will discuss first rule about symmetry. So y power is e1, then the curve is symmetric about only x-axis. So we will draw the dash that shaded area below to x-axis. Okay. Now come to the rule 2. So rule 2 is about origin and tangent at origin. So here if we put x equal to 0 and y equal to 0, so it's satisfied by 0 0 as the curve is passing through origin. Now if it is passing through origin, so we have to find out tangent at origin. So we will rewrite our equation by separating the degrees term. So it is x cube plus xy square, which is your 3-degree term, minus ay square, which is your 1-degree term. Okay, sorry, 2-degree term. So we have to put the lowest degree term, that is minus 2ay square equal to 0. So with this we will get y equal to 0 and y equal to 0. Again you have to write on it 2 times, right? So y equal to 0, y equal to 0. That means you are getting the same tangent 2 times, right? Then it is a type of cusp. Right, so here cusp, that means your 2 branches of the curve will touch same line 2 times. Got it? So now x-axis is your tangent, so we will draw the point and tangent on XOY plane. So this is our point 0 0, and at this point your x-axis, that is in red color, is the tangent 2 times. Okay, now come to the next rule, that is intersection with coordinate axis. So here 0 0 is the only point which is intersection from for x-axis and y-axis, because if we put x equal to 0, then we will get y equal to 0 in this equation, and if we put y equal to 0, then we will get x equal to 0. So no need to discuss this point again, because we already discussed in rule number 2. Okay, now come to the rule 4, that is asymptote. So asymptote about parallel to the x-axis and parallel to y-axis. So parallel to the x-axis, so we have to find out the highest degree of x. So here the highest power of x is 3, that is x cube coefficient is 1. So we can't put 1 as 0, that means no parallel asymptote to the x-axis. Okay, now just we will find out parallel to y-axis. So the highest power of y is 2 and y square coefficient is 2a minus x. So just put 2a minus x is equal to 0. So you will get x is equal to 2a. So x is equal to 2a is the only asymptote which is parallel to y-axis for the curve. So we will draw this particular asymptote on the curve. So this is x 2a 0 point and x is equal to 2a is your asymptote. Okay, that is in green color. Now come to the last rule, that is region of absence. So now you can easily identify this equation is solvable for y square. So you can rewrite your equation y square is equal to x cube upon 2a minus x. Okay, so if you put numerator and denominator of the right hand side of this equation is equal to 0, then you will get x equal to 0 and x is equal to 2a. So total x-axis here it is visible on XOY plane also, divided into 3 parts, that is minus infinity to 0, 0 to 2a and 2a to infinity. And one by one you have to put these values and you have to check whether your curve exists or not exists. So here in the first region curve does not exist, so we will put the dash area, and third region also the curve does not exist, so we have put here dash area. Now you have to draw your curve only from 0 to 2a, x equal to 0, that is y axis, to x is equal to 2a. Okay, so now let's start. First we will draw our curve at tangent and asymptote. At tangent, your curve will touch the tangent, and here at asymptote your curve will be parallel to the asymptote. Okay, so it is like this, and it is symmetric about x-axis, so it will be like this. Okay, so this is your curve. Okay, so now let's go for next example. So next example is x is equal to y minus 1, y minus 2, y minus 3. Okay, so we will draw this curve again on xy plane. Okay, so let's start with first. Here we can see x and y powers are odd. That means curve is neither symmetric for x axis nor for y axis. Even if we interchange x and y, means x is equal to y and y is equal to x, then also equation will change. Okay, so there is no symmetric at all. Okay, so now come to the rule 2, that is whether your curve is passing through origin or not. So if you put x equal to 0 and y equal to 0, so we will get left hand side is equal to 0 and right hand side is equal to minus 1 into minus 2 into minus 3, that is minus 6. So 0 is not equal to minus 6, that means your curve is not passing through 0, 0 point. So this question is different from the previous one because now it is not at all having any symmetry. It is not passing through origin. Okay, so pay attention here. Listen very carefully. So now the third rule, intersection with the axis. So intersection with the axis. So for y-axis and x-axis. So for y-axis we will put x equal to 0. So if we put x equal to 0, so we will get y equal to 1, 2 and 3. So we will get 3 points, that is 0, 1, 0, 2 and 0, 3. Okay. Now with the x-axis we will put y equal to 0. If we put y equal to 0, then we will get x equal to minus 6. That means minus 6, 0 is also the point. So we will get 4 points which are intersection with x-axis and y-axis. So we will draw these 4 points on the xy plane. So this is the first point, 0, 1, 0, 2, then 0, 3. Okay. Now here minus 6, 0. So these are the 4 points. Okay, as I already told you, whenever we will get points, we have to find out tangent at these points. Okay, so let's start. Let's find the tangent. So for to find out tangent, what you have to do? You have to differentiate this equation, that is x is equal to y minus 1 into y minus 2 into y minus 3 with respect to x, and find the dy by dx. Once you find dy by dx, so you have to one by one put the values of x and y as the point. Okay, so if we put x equal to 0 and y equal to 1, then the point is dy by dx at minus 6, 0 point. So first point we took as minus 6, 0. So we found dy by dx and put x is equal to minus 6 and y equal to 0. So we will get 1 upon 11. 1 upon 11 means it is positive. Positive means your tangent will form acute angle with the x-axis. So this red line is your tangent. Okay. Now the next point is 1, 0, 0, 1. So at 0, 1 you are getting as a positive value. So here also it will form acute angle. So this will be like this. Okay. Now at 0, 2 you are getting minus 1 means negative. Negative, that means you will have obtuse angle. So it will be like opposite. Okay. Now at the third point it is again positive, then it is again acute angle, then it will be your tangent. Okay, so I hope it is clear, because this in this equation your tangents are not parallel to x or y axis. Here it is positive or negative, so it will form acute or obtuse angle with the x axis. So just you have to assume you are drawing your tangent through the x axis. So your angle should be acute or obtuse from the x axis. Okay. Now come to the next, that is asymptotes. So here no asymptotes are there because here the highest degree of x is 1 and its coefficient is also 1, which can't be 0. And the highest degree of y, that is 3, and y cube coefficient is 1, which can't be 0. So no asymptote at all we are getting for this equation. Okay. Now come to the last point, that is region of absence. So there is no region of absence because you are not able to solve your equation for x square or y square. So for not for all values of x, y will be exist, and for all values of y, x will be exist. But here we can observe one more thing, that if y is negative, okay, so put the negative value on the right hand side. So negative into negative into negative, that means x is also negative. So if x is negative, then y is always negative. Okay, y is negative, then x is always negative. Okay, that means y is negative, x is negative, that means your curve mainly lies in your third quadrant. It will not lie in the fourth quadrant. For fourth quadrant, your y should be negative and x should be positive, but it is not the case. So whenever y is negative, your x will be negative only. So your curve does not lies in the fourth quadrant. So we will just put the dash area here in the fourth quadrant. So you have to draw your curve in the first, second and third quadrant. Your curve does not lie on the fourth quadrant. Okay. So now we will draw. So we will draw our curve first on tangents. Okay. So tangents we have to draw. So it will be like this. Here it will be like this and like this. Okay. So here one question may arise, because if we have a tangent, then your curve may touch from the both side. It can be one line is there, so your curve may touch from the above to that line or below to that line. So here at -6, why we are drawing our curve from the lower side of the tangent, not the upper side of the tangent. Okay, because at this point you are getting only a single tangent, that means your curve will touch only one time. Okay, if we will draw above to that line, so here if we draw here above to this line and we have to come at 0 1 point, then it is not possible to draw it smoothly, right? So you have to draw here smooth curves. That's why it should be goes below to that line. It should touch below to that line. And for this we don't have any point of inflection also. So here curve should be very smooth. Okay, so this will be the curve. Okay, now let's start with example. X into in bracket x square plus y square is equal to a into x square minus y square. So let's XY plane where we will draw our curve. Okay, so first we will find out the symmetry. So here x is appear, its power is 1, which means it is odd. Then it is not symmetric about y-axis, but y powers are even, then curve is symmetric about x-axis. Okay, so we will draw the dash shaded area below to x-axis. Okay, now come to the second rule, that is origin. So here if we put x equal to 0 and y equal to 0, then curve is satisfied by 0 0, hence your curve is passing through origin. So we will just put the point on the XY plane, that is 0 0, because your curve is passing through that point. Now if your curve is passing through that point, so we have to find out tangent at this point. So we will rewrite our equation as x cube plus xy square, that is your 3-degree term, then minus ax square plus ay square, that is your 2-degree term, is equal to 0, right? So we have to put the lowest degree term, that is a group of 2-degree term, ax square minus ay square, minus ax square plus ay square equal to 0. So we will get two tangent at origin, that is y equal to x and y is equal to minus x. Okay, so now these two tangents are distinct, so the point is a type of node. So here we will draw our two tangent, that is y equal to x and y is equal to minus x. Okay, now come to the point 3, that is intersection with x-axis and y-axis. So intersection with x-axis, if you put y equal to 0, so you will get x is equal to a. So now x is equal to a at y equal to 0, that means your point is a equal to a comma 0, right? So at a comma 0, you just find out dy by dx and put x equal to a, y equal to 0. So you will get dy by dx is equal to minus infinity. So if dy by dx is plus infinity or minus infinity, your tangent is parallel to the asymptote. At this point, your tangent is parallel to the y-axis. So we will draw here one point, that is a0, and a0 your tangent is parallel to the y-axis. Now intersection with the y-axis, we will put x equal to 0. But if we put x equal to 0, so we will get only y equal to 0. So the point is 0, 0. We already discussed this point in rule number 2. Okay. Now come to the fourth rule, that is asymptotes. So asymptote, so we have to find out parallel to x-axis. So highest power of x is 3 and its coefficient is 1, which can't be 0. That means no parallel asymptote to the x-axis. Okay. So x-axis के लिए we don't have any parallel asymptote. Okay, now come to the next term, parallel to the y-axis. So parallel to the y-axis, y highest degree is 2 and its altogether coefficient is x minus a. So just put x minus a is equal to 0. So you will get x is equal to x plus a equal to 0. That means you will get x is equal to minus a is your asymptote. So green color denotes the asymptote. Okay, now last point, that is region of absence. Okay, so again this equation is solvable for y square. It will break into minus infinity to minus a, and in that region y squared is negative, curve does not exist. Then from minus a to 0, y squared is positive, curve will exist. From 0 to a, positive, curve exists. From a to infinity, curve does not exist because y squared is negative. So these all parts we have here, and we have to draw the dashes line where the curve does not exist. So from minus infinity to minus a, curve does not exist, and from a to 0, a to infinity, curve does not exist. So curve exists only in between that region, x is equal to minus a to x is equal to a. Okay, so first we will draw a curve in between or about tangent and asymptote. So at asymptote your curve will be parallel, and near the tangent your curve will touch the tangent. So the first it will touch like this, okay, and then your one more rule is there, that is about a special point. So few graphs are having some special points, like few graphs are having isolated point. So we have not discussed till now that how we will draw the isolated point if any curve exists this isolated point. Similarly, maybe graph dependent on values of x and y. So maybe we have to put sometimes the values of x and y, and we have to check where the curve exists for those values of x and y. So I will give you the example for that in next slides. So these are some special point which point is not covered by earlier discussed 5 rules. So that will be under this category, that is a special point. So let us start with, so let's equation y squared into x minus a is equal to x squared into 2a minus x. This curve equation having some special point, so we will discuss that special point here. So now we want to draw this curve on x or y plane. So we will go rule one by one, which satisfy by this curve. Okay, so let us start with some first rule, that is symmetry. So for symmetry, we have to check all type of symmetry, and if we see the curve equation, then it is clearly visible that powers of y is even, then it is symmetric about x-axis. But no other symmetry exists for this curve. So we will take the shaded area to show the symmetric here. So now curve is symmetric about x-axis. Now come to the second rule. If we put x equal to 0 and y equal to 0 in this equation, then LHS is equal to RHS. That means your curve equation satisfied by x equal to 0, y equal to 0. Means your curve is passing through origin. Okay, so we will draw that point on x or y plane because our curve is passing through origin point. Okay, whenever we will get any point, so we need to identify the tangent at that point. So we will rewrite our equation and find the lowest degree term for this equation, for lowest degree term, and we will put it as 0. Okay, so if we rewrite and find the lowest degree term, then it will be y square plus 2x square equal to 0, and if we put it as 0, then we will get y is equal to plus minus 2xi. That means you will get y as imaginary, so you will get no real tangent for origin. Okay, that means origin is a part of curve, but we will not get any tangent. That means curve is not passing through that point. So I already told you, if this is the case, then this point is called as isolated point. Okay, so this is the part of curve, then it is essential to just draw this point, but your curve will not pass through this point. How it will so I will discuss when we will draw our curve. Okay, so now come to the third rule, intersection with the axis. So for intersection with the axis, we have to put x equal to 0 for y-axis intersection, but if we put x equal to 0 here, so we will get y equal to 0 only. So the point will be 0, 0 only, which we have discussed in rule 2. But if we will find out intersection with x-axis, so we have to put y equal to 0. If we put y equal to 0, then we will get x is equal to a. If x is equal to 2a, so the point will be 2a 0. Now we will draw this 2a 0 point on x or y plane, that this is the 2a 0 point. So now again we are getting one point, so we need to evaluate the tangent at that point. So for tangent, we will find out dy by dx from the given equation, and we will put x is equal to 2a and y equal to 0. So we will get dy by dx at 2a 0 point is equal to infinity. If slope is infinity, that means at that point your tangent is parallel to the y-axis. So that red line denotes the tangent at x is equal to 2a. Okay. So now come to the fourth rule, that is asymptotes. Okay, so we have to find out here both type of asymptote, parallel to the x-axis and parallel to the y-axis. So for parallel to the x-axis asymptote, we have to find out the highest degree of x, which is x cube, when we will multiply that x square with minus x, and its coefficient will be minus 1, which can't be 0. So there is no parallel asymptote to the x-axis. Okay, so there is no parallel asymptote to the x-axis, but if we have to find out parallel to the y-axis, so we have to find out the highest degree of y, which is y square, and its coefficient, that is x minus a, is equal to 0. So we will get x is equal to a is the parallel asymptote to the y-axis. So now we will draw this line on x or y plane. So this is x is equal to a, which is your asymptote. Okay, now the last rule, region of absence. So for region of absence, you have to solve your equation for either x square or y square. Here you can easily see that x square equation is not solvable for x square because x term also there. But this equation is easily solvable for y square. So you can rewrite your equation as y square equal to x square into 2a minus x whole upon x minus a. Okay, now put denominator and numerator of that right hand side of the equation is equal to 0. So you will get x equal to 0, x is equal to 2a, and x is equal to a. So now this minus infinity to infinity axis is divided into 4 parts. That is minus infinity to 0, means x is negative. If we put x is negative here, then we will get y is altogether negative because x square is positive, 2a minus x is positive, but x minus a will be negative. So the curve does not exist in that area. But now if 0 to a is their x, so here x square is positive, 2a minus x is also positive, but x minus a is negative. So altogether it is negative. Again the curve does not exist. Now if it is 0 to 2a, then the all values are positive, then y square is altogether positive, then the curve exists in this particular strip, that is 0 to 2a. But if x is greater than 2a, then again that whole y square will be negative, then curve does not exist. So we will take the dashes area to show where the curve does not exist. So it is minus infinity to a and 2a to infinity, curve does not exist. So only from x is equal to a to x is equal to 2a, the curve will exist. Okay, so here we will draw a curve. So you know the fact that we have to draw curve on tangent by touching it, and at the asymptote by taking the parallel curved line to the asymptote. Okay, so we will draw this curve. So here this is parallel to the asymptote, that is green line, and it touched to the red line because it is your tangent. Now it is symmetric about x-axis, so it will be drawn like this. So this is our curve. So here you can easily see that this is the curve which is drawn in between x is equal to a to 2a, but x equal to 0, that is 0 0, it is denoted by this red point. It is a part of curve, but it is a isolated point. That's why your curve is not passing through that point. So this is the speciality of this curve. Okay, so hope you understand this thing. So let's one more example where we can discuss one more special point for the so let's the last equation, that is y into x square minus 1 equal to x square plus 1. This equation also contains one special point, so we will discuss this after all 5 rules. Okay, so we want to draw this curve on xy plane, so we took here xy plane. So first we will check whether curve is having any symmetry or not. So here you can see the powers of x are even, then the curve is symmetric about y-axis. No other symmetry, you can check one by one, so no other symmetry exists for this curve. Okay, now the rule 2, whether this curve is passing through origin or not. So if you put x equal to 0, y equal to 0, then the left hand side is 0, right side is 1. That means 0 0 is not satisfy your equation. That means curve is not passing through origin, right? Here we took the dashes shaded part to show the symmetric about the y-axis. Now the third rule, intersection with coordinate axis. Okay, so intersection with coordinate axis, for that we have to put y equal to 0 for intersection through the x-axis. So if you put y equal to 0 in this equation, that means we will get x as a imaginary, because x square plus 1 equal to 0. That means no intersection with the x-axis. But if we put x equal to 0 here, then we will get y equal to minus 1. Means 0 minus 1 is the intercepts with the y-axis. So we will take this point on the curve. Okay. Now if you just differentiate this equation and put x equal to 0 and y equal to minus 1, then dy by dx will be 0. dy by dx is equal to 0. That means it is parallel to the x-axis. So we will take axis as a tangent at 0 minus 1 point, x parallel to the x-axis. So this red line is a tangent at 0 minus 1. Now next is asymptote. So I'm not just elaborating it because we have done lot of questions here. So I'm taking directly then the lines of asymptotes. So lines of asymptotes are x equal to plus 1. So we will draw by green line. So x is equal to 1, x is equal to minus 1, and y equal to 1. Okay, now this equation is solvable for x square. So for region of absence, we have if y lies between minus 1 to 1, then curve does not exist. So we will take the shaded area where the curve does not exist. I have not elaborated these 2 points in detail because we have done lot of questions. If you are not getting directly from here, you can take the notebook and one by one you have to do yourself according to I have described, and then you will get to know that these are the asymptote and that is your region of absence. Okay, because now here one special point is there. Okay, so what you want here, because it is symmetric about y-axis, so you want to draw only from x equal to 0 to infinity. So this region is break into 2 parts. See, it is x equal to 0 to 1 and x is equal to 1 to infinity. Okay, so if x lies between 0 to 1, okay, x lies between 0 to 1, that means x is less than 1. then y is negative. Understood? So if x is less than 1, then y is negative. That means from 0 to 1, your curve exists below to the red line. Okay. Now, but if x is greater than 1, then y is always positive. Okay. If x is greater than 1, then y is positive, means from x is equal to 1 to infinity, your curve exists to above to y is equal to 1 green line. Okay, so now we will just draw this curve. So here in this, I'll just mark yellow where the curve exists. Okay, between 0 to 1, curve exists as a negative because y is negative, so it is below to that, and from 1 to infinity, y is positive, so it is here. Okay, now here this green line is your tangent, sorry, this red line is your tangent. So at tangent at 0 minus 1, your curve will touch here, and for green line it is your asymptote, so curve will be parallel to with the red line. Okay, so now it's join smoothly. Now it is symmetric about y-axis, so you have to draw like same here, and that is your curve tracing. I hope it is clear. So that's it about the curve tracing, Cartesian curve tracing. So in first lecture we learned the rules which are very important to trace a curve. Without that you are not able to trace curve. And in the lecture 2 we have done lot of practice to trace curve. Okay. If you have any problem, so let us know in the comments or maybe in a Google Classroom. We will surely take your doubts seriously, and we will try to explain whatever doubts are there. Okay, so now next lecture will be for parametric curve tracing. So we will soon release our third lecture on parametric curve tracing. Thank you.